All right, I'm not going to maximize that because it doesn't like it. So, okay, so anyway, sorry about that. This is going to be section 2.1, which is entitled Functions. So let's try that again. So a function in its most basic form is just a relationship between two variables. In this class, most frequently we are going to use x and y for that. But just know that those variables could change. But here's how you know if it's a function. Each x is paired with exactly one y. In other words, no x is repeated. So depending on the format that you're given the function, you want to verify that no x is repeated twice, okay, and paired with a different y value as you go. So if I ask you maybe the most basic question about functions that I can, I want you to tell me, is it a function or not? And let's say that this relationship between x and y just included these 4 points. So a really limited basic function. So what am I trying to figure out if I'm trying to figure out if this is a function or not? Right, all the x's need to be different, right? And notice, do we have any repeated x's? We don't, right? So no x's repeat, right? Now there are some y's that repeat, but we don't really care about that, okay? We're really just looking at the x's. So remember, the first one in the pair is always the x. So yes, this is a function because no x is repeat at all. So in a function, y's can repeat, x's can't, okay? So that's one way to tell if something's a function. I tend to put stars by things that are really important that I want you to remember. So an alternative way to tell if something's a function or not is by the use of the vertical line test. And here's what the vertical line test says. It says that any vertical line that you could ever draw should only pass through the graph of a function once. And if it can pass through more than that, then it is not a function. So because a lot of times we're going to have an idea of what the graph looks like, either because we'll be given that or because we're going to use our graphing calculator that we talked about on the first class day that I'm recommending that you all kind of have access to at least, we should be able to quickly kind of look at a graph if we don't have one already. So if I asked you, is this a function, what would you tell me? Based on that vertical line test, what do you think? So picture this pen as my vertical line, right? No matter where I slide this vertical line, how many times am I only intercepting the graph every time? Only once, right? So that means this is a function. Okay, we'll have other examples, but that's just an example of something that's a function. What about a perfectly vertical line? Would that be considered a function? No, because if you drew the line right on top of it, how many points would you technically hit? All of them, right? So definitely more than one. So this would not be a function. Any sort of circle or oval shape would not be a function because how many times could a vertical line hit this graph? Up to 2 times, right? So it wouldn't be a function for that reason. Okay, so the easiest homework questions you'll have on this section are literally just asking you, is this a function, yes or no? Okay, so, and there'll be like a multiple choice option for you to choose, yes or no. All right, but what about when you don't have a graph? All right, so what about when you're just given an equation, which is, to be honest with you, going to be pretty likely that you may not be given a graph every time. So there's a couple of things. You can sketch this by hand, or you can use the graphing calculator, again, that's kind of recommended for this class. So let's kind of take a look at that, and then we're going to sketch the graph on our paper.
Is it x squared plus 3?
It is x squared plus 3. I really wish I could make that bigger, but I'm afraid if I do, it's going to get mad and decide it's going to quit again, which I'm not really sure why it's doing that. So when you want to graph something on your graphing calculator, you go to your y equals button. So I'm going to enter in x squared plus 3. And remember what I said on day one, if you don't have a graphing calculator at home, there are several free graphing calculator websites you can find. One of them is Desmos, spelled D-E-S-M-O-S. But you can use those. They're not quite as user-friendly as I think as the TIs, but they're free. Okay, so that's an option. We also still have some calculators for rent in the math department if that's something that's of interest to you too. You rent it for the full semester, and you can hold on to it and use it for all your classes for the full semester. All right, but once you enter in your y equals, we're going to graph it. So notice what shape it is. I know it's kind of hard to see. It's kind of in the glare a little bit, but the lighting's not super, super great on this document camera. So basically it's just a parabola shape and it's shifted up 3 units. So maybe kind of take a look at what sketch I drew there. So just draw yourself 3 little marks above the x-axis and then draw your parabola from there. So we may not have started off with a graph, but now that we have one, would this be a function, yes or no? Yes. Yes, because now that we have a graph, it passes the vertical line test. So for the most part, the vast majority of this class, we're only going to look at relationships between x and y that are in fact functions. Okay, but the first thing is we need to determine if it is one or not. All right, so when we're discussing functions, there is some notation that I want you to know. So another way to write y equals x squared plus 3 is the following. Instead of y equals, we say f parentheses x equals x squared plus 3. In this phrase right here, we literally say this as f of x. But when you see this notation, you can know it's a function, okay, because it's already listed in that notation. So this notation as a whole is called function notation. So if you see f of x, and by the way, it doesn't have to just be the letter f, it could be g or h or some other letter. If you see a letter, parentheses of x, then that's telling you that it's a function. Yes?
Do you mind if I look there? I can barely see.
Yeah, I mean, as long as you sit. I don't even know why these are kind of like that, but you can move one of those like even with her, you know what I mean? Like right there, yeah. I don't think those are 6 feet apart anyway. So yeah, that would be fine. So a good thing about function notation is we can do a lot more with it. Okay, so if you see something like this where it says f of 5, okay, f of 5 means that it's trying to tell you what the x, actually make sure you're like even with him. See what I'm saying? So that we're, yeah, thank you. So it's telling you what the x value is, and it's asking you to do what? How do you find f of 5? Maybe from another class that you took.
Would you find 5 for x?
Yeah, you're going to replace x with a 5, okay? So in other words, you're going to get 5 squared plus 3, and then we're just going to need to figure out what that is, okay? Make sure you do order of operations. So we would do which part first, addition or squaring? The square first, right? So we would get 25 plus 3, or 28. So I not only want you to know that the answer there would be 28, but I want you to know what this answer represents. What this means is this is the y value when x is 5. So when you're asked for f of x or f of a number, you are always being asked to find the y value in some form or fashion. So y equals f of x. Those are one and the same. It's just another way to write y, and it's going to allow us to do a whole lot more than just using the letter y will. Okay, so using that same kind of function notation, let's look at maybe a different function. So I want to do plenty of examples of this so that when you get to your homework, you know what to expect. So if this is the function we're working with, I want you to find the following three values. So notice that I'm using different letters this time. I'm using R in place of X, okay? And instead of the F letter on the outside of that function notation, I'm using G instead. Okay, and remember, because I'm recording this, you could always go back and rewatch any of this that you wanted to later on. So what does G of negative X mean? The G tells you which equation to look at, right? So it's telling you to go find an equation that is called G. And what's it asking you to plug in for this time, the R value? So it's asking you to go find this equation and stick in the number -6 in for R, okay? So it's going to be the square root of -6 plus 6, and then plus 3 at the end, not under the square root. Okay, so notice what I did there. I just rewrote this exactly as it is, but in place of R, what did I do? I put in -6. So the only thing I did was insert -6 where the variable was. But then I think we can work this out. Okay, what is -6 plus 6? 0, right? So the square root of 0 plus 3 is what I would have, but what's the square root of 0? There's not really anything going on there. What is it? Just 0, right? So the result I get is 3. And again, I want you to be able to describe that that means that the y value is 3 when x is -6, or in this case, when r is -6. We're using r instead of x in this problem. Okay, so what will be different if I ask you to find g of 10? Same concept, but what will I insert in for the variable this time? 10, right? So it'll be square root of 10 plus 6, and then a plus 3 on the outside. So just like I did before, let's clean up under the square root. So 10 plus 6 is just 16. And then I can take the square root of 16, right? The square root of 16 is what? 4, right? So I'm going to get 4 plus 3, or what for my answer? 7. So I won't make you write it, but how would you describe what this 7 is? The what when x is 10? Which value? The y value when x is 10, or r in this case, okay? But same difference, okay? So it really doesn't matter what shows up in the parentheses. Whatever's in the parentheses, whether that be a number or whether in this case it's an expression involving a variable, what are we going to do with that whole x minus 6 thing then? We're going to plug it in, right? So instead of square root of something plus 3 or square root of r plus 6, we're going to insert the x minus 6 in for r. So notice the structure is exactly the same if you compare them, right? All it did here was pull out the r and stick this in. Okay, everything else is the same. It's something plus 6, the square root of it, plus 3, and this is the square root of something plus 6, plus 3. So we'll clean it up as much as we can. What could we clean up? Like minus 6 plus 6, what happens to that? 0. It's a 0, right? So we end up with the square root of x and then plus 3. Notice these are not like terms, so there's nothing I can do with that. So it shouldn't maybe surprise us, but sometimes when you insert a variable, you should probably get an expression involving a variable back out again. Okay, so not to be goofy about this, but basically I just want you to understand what it is that it's asking. You don't have to write this down, I just want you to be able to verbally tell me. So if I tell you to find g of Texas, which doesn't really make mathematical sense, what would I want you to do though? It doesn't matter what's here. What do you do with what's in the parentheses? Plug it in, right? So it would look like the square root of Texas plus 6 and then a plus 3 on the outside. Like it doesn't matter what's there, just plug it in. Okay? So in your homework, you'll have an opportunity to practice that. All right, so let's look at something else with functions that I want you to know. So when we get to especially graphing them, we're going to want to know what x-intercepts and y-intercepts are. The reason I put that s in parentheses is because we can have more than one. So it could be a singular x-intercept or more than one of them. But what in general is the x-intercept? Where the graph does what? Where the graph goes through or crosses the x-axis. And so a good way to find this is just going to be where y equals 0. Okay, because if you're on the x-axis, then think about it this way, you're not going up or down at all, so your y value will be 0. Now for the y-intercept, and I'm not going to make this one plural, we'll talk about y in a minute, there's only ever one of these if it's a function. But this is, of course, where the graph crosses the y-axis. So how do you guess you would find it? If you find the x-intercept by setting y equals 0, how do we guess we would probably find the y-intercept? Set x equal to 0. Okay, can you think of visually why there shouldn't be more than one y-intercept if it's a function? So think about what that would mean in your graph. So what test would it fail if it happened to have two y-intercepts? It would fail the vertical line test. That's why I'm saying functions should not have more than one. Okay, y-intercept, but they can have multiple x-intercepts. All right, so you will probably see something like this show up on your comp exam when you take it this week. So let's see if we can show the work here. So what if I asked you to find the x and the y-intercept of 3x minus 5y equals 30? Okay, so before we actually work anything out, let's just talk about how we're going to find each of them. For the x-intercept, I'm going to set y equal to 0. And for the y-intercept, I'm going to do what? Set x to 0. Okay, so let's do that. So for the x-intercept, I'm going to get 3x minus 5 times 0 equals 30. But what do we know about anything times 0? What happens to it? It's 0, right? It goes away. So I end up with 3x equals 30. And so if I want to know what x is, what's the last little arithmetic step I need to do here? Divide by 3. So I end up getting an answer of x equals 10. Just know that a lot of times MyMathLab is going to want you to enter this as a point, like a x comma y point. So what would the x comma y point be for x equals 10?
10, 0.
Yeah, 10 comma 0. So I'm going to circle kind of both of these formats because MyMathLab is going to specify which one it wants. Most often, to be honest, it's going to want the point notation. So let's do the same thing here. Now let's set x equal to 0. So 3 times 0 minus 5y equals 30. So once again, what happens to anything times 0? It goes to 0, right? So we get negative 5y equals 30. And then what? Divide by negative 5, good. Okay, be careful of your signs, okay, because a positive 30 divided by a negative 5 should be a what kind of answer? Negative. So we end up getting y equals negative 6. Or what would this point look like? And think about that. This time the y is negative 6.
0.
Yeah, so it'd be 0 comma negative 6. Okay, so be paying attention on your homework to which format it wants. Okay, definitely make sure you can do kind of both there. Okay, so the next big thing that I want you to be able to do when you have a function is I want you to be able to tell me what the domain and the range are. Okay, so I want you to be able to find intercepts. Okay, well first I want you to be able to tell me if it's a function. Okay, then if it is a function, I might want you to find the intercepts. And then I'll definitely want you to be able to tell me what the domain and the range are. So the domain is the x values and the range is the y's. I usually remember this because it's in alphabetical order, right? D comes before R alphabetically and X comes before Y if you tend to maybe misplace those. So I think domain and range is kind of easy to remember as far as which one's which. What can be difficult, and that's why I'm putting 2 stars by it, is we are going to want you to use throughout this entire semester something called interval notation. So I'm going to briefly go over it here. This also shows up on your competency test. So we're doing a lot of things today that actually are showing up on your comp exam anyway. So if you can combine today's lesson with what we talked about last week, you have most of the comp already reviewed for you. Okay, and the rest you can look at the answers on the back of that page that I handed out on the first day. All right, so first of all, with interval notation, we're either going to use parentheses or brackets, or maybe a combo of both. Okay, so we use parentheses in two scenarios. You use it when you are not including an endpoint, and we're going to look at some examples of this, or you use it with positive or negative infinity. And then you use a bracket when you are including an endpoint. So not only am I going to want you to tell me what the x and y values are, but I'm going to want you to be able to write it in that interval notation. So we already mentioned that the domain was the x values. So here's how that's going to look in interval notation. Now, which, axis is the x-axis? Is it the horizontal one or is it the vertical one? It's the horizontal, right? So think about thinking horizontally here. So what you're going to start off with is either a parentheses or a bracket, depending on whether you're including the endpoint or not, or whether you have infinity, okay? And you're going to begin with your left starting point, and then you're going to have a comma, and you're going to end with your right ending point. And again, you're either going to have a parentheses or a bracket depending on the situation. Okay, so we're going to practice a few of these in just a minute. So for the domain, you only care about x values. So you only look from left to right since the x-axis is the horizontal one. Okay. So for the range, you only care about which values, not the x's, but the what? But the y's, right? So which axis is the y? Is it the vertical one or the horizontal one? Vertical, right? So here's the way that the range will be written. Again, we'll start off with parentheses or bracket, depending on the situation. Okay? And then you will begin by writing the bottom start point, and then you will end with the top end point. Good. So the gist is, for domain, look left to right, and for range, look bottom to top always. Okay. It can be tempting to try to look top to bottom just because that's usually how our eyes read things. But it's always smallest value first, followed by bigger value, so you always have to start at the bottom first. All right, so I'm going to put a star by this example. This is one of those things that once you get it, you'll be like, oh, I totally understand how to find domain and range, and I'm not sure why I struggled with it before. But like until you reach that point, you've got to keep practicing with different looking graphs, because it's largely a visual exercise. Okay, it's largely knowing what to look for and, knowing to pay attention to either the horizontal values or the vertical values, depending on whether it's domain and range. So I don't want a whole lot of detail to these graphs, but maybe just a little bit. So for graph A, I want you to draw this parabola looking thing that's been shifted down to. We're going to find the domain and the range for each of these. It's probably easiest if you draw the points that I mentioned first and then try to draw the shape. So here I want you to draw an open circle at 2, 1, and then I want you to kind of curve it up and out after that. And then for the final graph, I want you to make an open circle at 1, 3, and then a closed circle at 2, 0, and connect them with a little segment there. So it's easiest if you draw the points first and connect them so that you've got things in the right spot. So I'm just going to set these up for answers. So I'm going to have a domain and range on each of these. And we just need to learn interval notation now, because a lot of the things that you'll be doing later on will also be in interval notation. So the sooner we can learn that, the better. All right, so domain is only concerned with what? I kind of left it on screen for a reason. Which direction to which direction? Left to right. Okay, so if you look at this graph on A, if I had to ask you how far back this graph is going to go, now I'm not asking you where it's crossing the x-axis. That's not what I'm asking. Okay, I'm asking you how wide is this graph going to get if we keep drawing it? It's going to get as wide as we can think of, right? Like this is going to go all the way back and back and back and back until it can't go anymore, right? So it is going to go back to negative infinity. It goes back forever, and that's how we say forever is infinity. Okay, and then how far to the right will it travel if we keep letting it get wider? Positive infinity. Remember, we always use parentheses for infinity. Think of it this way, like you can't include infinity. Okay, infinity is not an actual tangible value, right? Like I'm not going to give you my credit card and tell you that your spending limit is infinity, because that would mean you wouldn't have a spending limit at all, right? You could just keep going. I'm not going to do that, by the way. Either way, you don't want my credit card anyway. There's hardly any money on it. All right, so what about range? I don't care about left to right for range, right? What do I care about? Up and down, but more specifically maybe down to up, right? We want to start with the bottom, okay? So do I have a bottom start point? I do, right? I start at -2. So the question is, yes, we do use a bracket because it's not an open circle or anything. An open circle means don't include it. If it's solid, you're going to include that point. But then if I had to ask you how far up this is going to go, what do you notice? It goes up forever, right? And we write forever as infinity. Okay, so that would be the domain and the range for the first one. All right, so let's look at the second one. Okay, same concept. Domain, I just care left to right. Range, I just care bottom to top. Okay, so what about domain? Do I have a left starting value for domain?
2.
I do start at 2, right? But what do you notice about the open circle? What would that mean? Yeah, so I want to say 2 because it goes right up to 2, but it just doesn't include 2. Okay, and then how far to the right will I travel? Forever, right? So infinity. Okay, what about range? I don't care about left to right, I only care about what? Bottom to top, right? So what's the bottom, the lowest y value that's represented? Yeah, so it's going to be 1 with a parentheses, good, again because of the open circle. And then how far up is this going to go if we keep drawing it? Yeah, it looks like it goes up forever, so we'll say infinity. All right, so in my opinion, I think graphs like part C are the toughest because we have an open circle and a closed one. So let's make sure we can do that too. All right, so the domain, I know that I drew it a little close, okay, but where did I want you to start that line, x-wise? Yeah, we did start at 1. It may be a little unclear with the way that I drew it. Okay, we started at 1, and how come I used a parentheses? What kind of circle does it have? Open, right? And then I end at what x value? 2, but that one's closed, meaning what? Meaning I use a bracket and not a parentheses? Okay. So then last but not least, now I'm looking at the range, right? So range, I look bottom to top. So what's the lowest y value that I have represented?
0.
A 0, and it's solid, so what does that mean? Bracket. And then I go up to what highest point?
3.
Y value of 3, and I use a parentheses because of the what kind of circle? Open circle. Okay. So probably more so than most things, if domain and range are like still a little shaky for you, there's definitely going to be some practice problems on your homework, but you can also Google search like domain and range practice. There is all kinds of stuff out there on this because it's a really commonly sought after topic. Okay, so you really should be able to find just about anything you would want there. All right, so let's do one more example And then we're actually going to start on a new section. This one's a really, really short one. So I do want to start looking at some problem-solving questions. Problem-solving is just a really nice way to say word problems. Okay, I know in the past most of us don't just love word problems. It's not like you say, oh man, I hope we work on some word problems today. But word problems are just applications of what you should know from class. So they're really not to be intimidated by, but I get that they can be intimidating sometimes. So we're going to start to kind of look at them today, and then we're just going to kind of mix them in throughout the semester. All right, so let's say a company manufactures CDs with a fixed cost of $15,000, and then it costs $2 per CD to manufacture. So we'll look at all those details in just a minute, but what I want you to do is I want you to find the total cost function if X equals the number of CDs. This symbol means number in math. It's not just a hashtag. It also means the word number. And I also want you to find out how many CDs are produced if we're spending $15,500. So notice I'm asking you to write a function. So I'm asking you to basically write an equation, okay? And then we're going to see if we can kind of work in all of these values. So before we start to write things down, what would a fixed cost mean? What does the word fixed mean? It doesn't change, right? So like if you go get a car and you get a fixed interest rate, which you should when you buy a car, FYI. If you get a fixed interest rate, then that means what's not going to happen to that interest rate. It's not going to change, right? And then it costs an extra $2 per CD. So let's first, I'm going to call the cost C of X. So why am I not using F or G or something like that? Because C stands for what? Cost, right? So you can use whatever letter you want. So often in word problems we'll use the letter that represents what we're trying to find. So we've got C of X equals, so first I'm going to start off with the 15,000 because we already talked about that part is remaining the same, right? We don't have to worry about that. Okay. But then how are we going to write $2 per CD? If we just say plus 2, that only covers one CD. Okay. Would we probably make more than one CD if we were manufacturing CDs? Probably so, right? So how am I going to write that? Yeah, so I'm going to say 2 times the number of CDs, and notice I was told to call the number of CDs what letter? X. Okay. So notice this is the first thing I was asked to do in this problem. So like I've actually done the hard part. So the cost equation is 15,000 no matter what, plus an extra 2 times however many CDs we make. And if you think about it, that will work, right? If you make 1 CD, what's the extra charge? $2, right? But if you make 100 CDs, what's the extra charge? 200, because 2 times the 100 CDs is 200, right? So that's going to work just fine. All right, so the second part is I want to find out how many CDs are produced at a cost of $15,500, okay? So I almost always have students kind of quickly do this. I wouldn't want to plug $15,500 in for X. How come?
That's the number of CDs.
Yeah, that would be how much would 15,500 CDs cost, and that's not what I'm being asked to find, right? I was given the cost, so where should I put this in for? Yeah, this is the cost, so I'm going to put it in for C of X. So I'm actually going to put 15,500 here. And then notice I just have a couple step arithmetic / algebra problem to solve. So now I'm going to move the 15,000 over. Whatever I do to one side, remember in algebra I have to make sure I do the same to the other side. So here I'm going to get 500, and here I'm going to get 2x. So I'm almost there. Now what? Divide by 2. So the second part of this question would be how many CDs? 250 CDs. Okay. Which if you think about it, that actually should make logical sense, right? 15,500 is 500 extra dollars. And so if we're talking about $2 each, it must have been 250 CDs. Yes, the biggest things I want you to take away from this section is how to tell if something's a function or not. And really the major thing that I want you to be able to do, although X and Y intercepts are important, the biggest thing I want to make sure you can do is domain and range. Those are going to be the most common things that you're going to see throughout the semester, because we can review the intercept things kind of as we go.